Hi, hello, this is Panir. In this video, we are going to see about pharmaceutical inorganic chemistry unit number 3, that is acid base titration. Under this unit, we are going to cover the following contents that are what do you mean by titration and types of titration, in that what is acid base titration, then expression of concentration of the solution, uses of acid base titration, what is the mechanism behind in this acid base titration, what are the types are there in the acid base titration, finally what is the choice of indicators. These are all the contents we are going to see one by one. What is titration? In titration, a standard solution is added to solution of unknown concentration in a conical flask using a burette. What are all the types of titration? Acid base titration, redox titration, compleximetric titration, precipitation titration, non-aqueous titration, etc. You need to know that in the titration process, what do you mean by titrant? What do you mean by titrant? Titrant, a known concentration of a solution used in the titration, which is there in the burette or used to call burette solution. What is titrant or analyte? The titrant is any solution that contains an ion or species being measured and to which the titrant is added. Used to call conical flask solution as a titrant. This and all you need to know that. What is acid base titration? In a quantitative analysis, a one shot of titration known as acid base titration, which is used to estimate the concentration of an acid or base by neutralizing it. The process of determination the concentration of acid or base by measuring the volume of titrant, which is already known to have a certain concentration, that interacts with the acid base in stoichiometric reaction involving the transfer of proton. This is what acid base titration. Now we need to know that what is the stoichiometric reaction. Stoichiometry is the quantitative study of chemical reaction, reactant and products. And the term refers to the field of study known as chemical stoichiometry. This word is derived from Greek "stikein", which means element, metron, which means measure. This is the meaning of stoichiochemistry. So now you need to know what is acid base titration. When the acid base titration come into your mind, first thing it's a quantitative analysis. The second, this reaction is a neutralizing reaction. These two things you have to keep in your mind when acid base titration is to come in your mind. Now, how to describe or how to express the concentration of solution? The concentration of solution is expressed by normality, molality, molarity, mole fraction, weight percentage, volume percentage, concentration in ppm, percentage concentration, concentration in gram per liter. These are all the ways you can express the concentration of solution. We'll see one by one. When we express the concentration of solution, there are two things will come. One is qualitative analysis, other one is a quantitative analysis. Through qualitative analysis, we can express the concentration via diluted solution. Other one is concentrated solution. Diluted in the sense it has less solute. Concentrated solution in the sense it has more solute. That's it. This is what the qualitative analysis via what we are going to and how we are going to express the concentration of solution. Then how to express via quantitative analysis. Through the quantitative analysis, we can express the concentration of solution through W by W, means weight by weight. That means mass of compound in solution divided by mass of solution into 100. For example, 10% of glucose in water, it means 10 gram of glucose in 90 gram of water. That is the meaning of weight by weight. The same formula applicable to other all. If you are taking volume by volume of compound divided by volume of solution into 100. Example, 10 percentage of ethanol in water, which means 10 ml of ethanol in 90 ml of water. That's it. In the way, weight by volume. The formula is mass of solute divided by volume of solution into 100. This W by V mainly used in pharmaceutical industry, especially pharmaceutical analysis experiment. Then what is parts per million? This is especially to analyze trace elements like air pollution and elements like sodium, potassium, what is present in trace amount of any of the solution. In that case, we can use this parts per million. And the formula is number of parts of compound divided by total number of parts of all the compound into 10 to the power of 6. This is the formula for parts per million. Next is mole fraction. The formula is number of moles of compound divided by total number of moles of all compound. If you are having combination, one or two compound present in one solution, to know one particular compound concentration, then you can use the mole fraction. By using the mole fraction, you can easily identify the mixture any one of the compound concentration. And the next one is molarity. Is widely used in pharmaceutical chemistry. The molarity calculation for especially synthesis. The formula of the molarity is number of moles of solute divided by volume of solution in liter. Which means if you want to know any of the compound molarity, first you have to calculate the molecular weight of the compound, then the amount of compound taken and mixed into 1 liter of water, you will get molarity of the particular compound. What is molality? The formula is number of moles of solute divided by volume of solvent in kg. Molarity in liter, molality in kg. That is the only difference. Normality, the formula number of gram of equivalent of solute into 100 divided by volume of solution in liter. Gram equivalent mass, mass of solute divided by equivalent mass. Equivalent mass formula is molecular mass divided by number of H plus and OH minus ion. These are all the way you can express the concentration of solution. One is qualitative, other one is quantitative. These are all the basic things you have to know to approach any of the pharmaceutical experiment in better way. Now we'll come to acid-base titration. What is the use of this acid-base titration? Acid-base titration is used to identify the concentration of acid or base. Second one, whether unknown acid is strong or weak, whether unknown base is strong or weak, what is the pK value of unknown acid and pKb value of unknown base. This is the main use of this acid-base titration. The next is what is the mechanism behind in the acid-base titration. Let's think about an acid-base reaction. It is going to and need a proton acceptor. See, most of the time the proton is solvated as H3O plus in water by adding water to the base. You can either lose OH minus ion or gain H3 plus O ion. Here, this equation clearly mentioned acid reacts with water, you will get H3O plus ion. Base reacts with water, it gives you OH minus ion. This is what happened. If it is acid and base reacts, it used to give conjugated base and conjugated acid. Okay. Acid reacts with water, it used to produce conjugate base. Base reacts with water, it used to give conjugated acid. This is what happened in the acid-base titration. This is the mechanism begun in the titration. Okay, now what is conjugated base and conjugated acid? You need to know, right? When a proton is added to a base, a conjugated acid is made. When a proton taken away from acid, a conjugated base is made. That's it. This is what the conjugated base and the conjugated acid. Next, Types of acid-base titration. There are four types. One is strong acid versus strong base. Example is hydrochloric acid and sodium hydroxide. Second one, weak acid, strong base. Ethanoic acid and sodium hydroxide. Third one, strong acid, weak base. Hydrochloric acid and ammonia. Finally, weak acid and weak base. Ethanoic acid and ammonia. These are the four types is there in the acid-base titration. Next, choice of indicators. Acid-base indicators are things that change the color or become cloudy when the pH level changes. Point number two, they also measure pH and find the equivalence point. Point number three, they are either acids or bases, can be dissolved in water, don't change much in color, and are stable. Fourth point, the change in color is caused by a resonance of electron isomerism. Because the ionization constant of different indicator are different. They change color at different pH levels. This is all about how the indicator is to behave. Now, what is the choice of indicator for acid-base titration? Number one is phenolphthalein, number two methyl orange, number three is melazite green. Phenolphthalein is a combination of phthalene and sulfathalene. Azo indicator is to call methyl orange. Terphenyl methane indicator is to call melazite green. If it is strong acid, strong base titration, then indicator is phenolphthalein. Weak acid, strong base, then phenolphthalein is an indicator. Strong acid and weak base, methyl orange is the indicator. If it is a weak acid and weak base, you can use either phenolphthalein or methyl orange. This is all about acid base titration. I hope this video is useful. In that case, I used to ask, do the like, subscribe my channel, finally share those who in need. Thanks for your valuable time. Thank you once again.